Ma'am, I
Yeah.
received
Yes.
I received
Yes,
the
please.
link for past year paper solving only for UCEED and CEED, and that class
Mhm.
was scheduled for 6 p.m. only. So do I need to attend another
No,
class?
it is 6 a.m. Can you please check it properly?
Just let me check here.
It is 6 a.m., not p.m.
So, ma'am, is it scheduled every day?
Every day, 6 a.m. morning, not
Okay,
evening.
okay, got it.
Okay. Yeah. There'll be two
Thank you.
classes. One will be in the morning, which is a past year question discussion, and one will be in the evening, which is a fundamental topics. You will know about the topics, and if you missed any topics, you can recall them. Or if you've already attended it, just a kind of one kind of revision what you're going to have this session. Okay?
Okay, got it.
Yeah.
Yeah,
Fine.
okay.
Fine. Let me just start the topic. See, we have visual special ability. Majorly, I need to know few things when I'm doing visual special ability. What you know? So generally, a few basic concepts, which is I need to know about what is a vertex, okay, and I need to know about what is edge and what is the surface. These three concepts are very, 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 very important because all my topics, which is under visuals, will be with these three topics. These three basic concepts, okay, majorly. So, what is these three basic concepts? See, generally, when we heard this called vertex, what comes to your mind? When you heard this name vertex, what comes to your mind immediately after just heard this word? Just a second. Sorry, sorry. Yeah, I'll repeat again. So once you hear this word vertex, what comes to your mind?
A point,
Point. Okay. Next point.
a
Corner.
junction,
Corner. Okay. Point. Corner. Junction. Okay. Next. Any other words? Okay. So point, corner, junction. Almost kind of same. Okay. So it's a similar to vertex definition. See, generally vertex is a point where two or three lines meet. So when I say two or three line means it could be a corner, it could be a junction, or it could be just a point also, right? So vertex is a point. So whenever you have any kind of surfaces, the corners will become a vertex. The corners will become a vertex. So generally, we when we are in our childhood, they'll say edge. We would have heard this as edge, right? Sometimes they used to tell this as an edge, but it's not an edge. It's a corner. Okay, then what is the meaning of edge? What do you know about edge?
Lines which form the corners are the edges.
Yes, the lines that forms the corners or the edges. Okay. Okay.
the sides of a 3D figure,
The sides of a 3D figure. Okay. Next.
a line
In the
connects two surfaces,
Line cuts two surfaces. Okay. Next.
intersection of two faces of a polyhedron or polygon
Okay.
something.
Intersection of two faces. Okay. Next. Only this much? Okay. I'll tell you one point. Edge is a very easy thing. You know what? We have two types of lines generally occurs in your geometry. One is a straight line. The other one is an edge. You know what is the meaning of straight line? What is the meaning of straight line? What is the meaning of straight line? A basic definition. What do you know about straight line? What is straight line?
It has two ends which extend to infinity.
It has two ends which extend to infinity. That's good. Next.
Then straight line just connects two points to each other.
Straight lines are connecting two points to each other. Okay, next. That's all? Okay. See, straight line is what you have an end point. There'll be a line between two end point. There'll be initial and final. Okay. Sometimes you may have initial and final. Sometimes it could be infinity in the both the ends. But you will have an end point in two places. There will be a starting and an ending. So it's a line between two endpoints. That's a straight line. But when it comes to edges, it's a line between two vertices. What is it? Vertices, and the thing is, see, I'll tell you an easy example. I'll draw a line from this point to this point, and I'll put a points in between. Okay, I'll give a name to this. Okay, how many straight lines are there in this figure?
One only.
5,
How
ma'am.
many? Yeah, how many
Five.
straight lines are there? 5. Okay. Next.
6.
6. Okay, I have 5 straight lines, 6 straight lines, and 1 straight lines. Next.
12 or 13.
12 or 13 straight lines. Okay, next. Okay, I told you one basic definition when I started with straight line. It's a line between two endpoints. Can you just tell me now how many straight lines are there here? It should be an end. You can't have a continuation over there. Then how many straight lines are there in the actual figure? Who said 1?
Is it 5?
5. No, it's actually 1 straight line. See, straight line ka meaning it's a line between two end points. You need to have an end. No continuation should happen. Here, when I say 5, there is a continuation with the points, right? But here, when I define a straight line, it is A to F is what my straight line is. There will be only one straight line, which is A to F. But when I'm talking about edges, it's a line between two vertices. So what happens? I'll have the separations here. I'll have one vertex, one edge, two edge, three edge, four edge, and five edge. There are 5 edges. This is what the difference is between straight line and edge. See, straight line is like you need to have two end points. Both should be open and there'll be one straight line. Okay? But when it comes to edges, it's a line between two vertices. Okay, 2 points generally. So that means when I say here A to B will be one edge, B to C will be one more edge, and C to D will be one edge, and D to E is one, and E to F is one. Are you clear about the straight line and edge?
Yes, ma'am.
Why I
Ma'am?
told you this
Yes,
difference?
ma'am.
Yes,
Yeah,
ma'am.
why? Yeah,
Excuse me, ma'am. Now only you are starting that visual spatial ability.
yes. Just now I started, don't worry. See, when I'm talking about this, why I told you the straight line difference and edge difference, because sometimes they in your question they'll ask you to count straight lines. There'll be multiple lines. Okay, you need to be very clear what is the straight line, and if they ask you to count the edge, you need to be very clear what is your edge. Okay, so that's the reason I've just made a difference between these two. Now coming to our point, one more thing called faces. You know what is the meaning of faces? Or I can just say surfaces. Both are almost the same. Surfaces or faces. So this obviously comes in our 3D figures, right? So whenever I take a cube, just think I'm taking a cube. So faces is generally how many surfaces you can see, okay, with a different view. For example, if you take a room, there will be 4 walls in the room, and one will be on the roof, the other one will be on the bottom, right? So you totally have 6 surfaces when it comes to a room. Same way when it comes to a cube also, you can see 6 surfaces. Do you agree? We can see 6 surfaces: front, back, top, bottom, left and right views. So there are 6 different surfaces. So whenever I see surfaces, it's faces. You need to have the separations between the faces. When there is a separation, then we consider as 2 faces. If there is no separation, then we consider as only 1 face. Okay. So now I'll show you a few examples we can do with edges, vertices, and surfaces. See here. Okay, this is a question now. I need to count how many vertices are there in this figure. Just a minute. Yeah, sorry guys, sorry. Now we need to count how many vertices are there in this given figure. So I told you vertices is nothing but it's a line between two end points or 2 points. Okay. So now, sorry, I'm talking about edges. So I'm talking about vertices, right? So it's a point between two lines. Point between two lines. Okay. So when we are defining this way, now can you just tell me how many vertices are there here? So I think it's visible here. So they are saying 17. But generally, I need to know exactly how do we count the vertices, right? So how do we start with the vertices counting is very, very important because don't start counting the vertices randomly. When you start counting the vertices randomly, you'll end up with counting sometimes twice or you may miss one or the other vertex. Okay, what I suggest you is have certain rules. I'll just move on to left to right or I'll come from top to bottom. Anyway, just fix one particular way and start counting it. Just say I'll count from top to bottom. Then I'll start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we can see 15 vertex. Do you all agree?
Yes, ma'am.
Yes, ma'am.
But always remember one point. Bottom is a rectangle. Do you agree? Bottom is a rectangle.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Generally, rectangle means how many vertex will be there?
4, ma'am.
4.
If
Four.
you take any view of 3D figure, you can see only 3. One will be always hidden. Remember, one will be always there, but you won't be able to see them when it is a 3D figure. So remember, bottom one should be added always. Next, with respect to your figure, just see is there any hidden vertex. Can you see here? It's an L shape. Obviously, the next to this also should be an L shape. Do you agree?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Then here also we need to have one more vertex. That's one more.
Yes, ma'am.
See, this one is always fixed. The bottom one is always fixed. And this is with respect to the figure. You all got my point? So when you're solving your question, whatever it is, bottom may you can see only 3. Okay? Almost the bottom will be either a square or a rectangle. So that's the reason if you can see 3, just count one more, which is 1 is hidden. This is always fixed when it comes to vertex. Okay, and this is with respect to the shape. So totally it is 17. So what you need to do is whenever you are trying to count, make sure you count visible first, then try to count the hidden one. Okay, then you'll get the proper answer for it. Because getting an answer is not that important. You need an accurate answer. That's a very important point, okay? Because you have only less time when you're doing it in your exam, right? You don't have much time. You can't take 1 hour or 2 hours to answer one particular question, right? So you need only 1 minute or half a minute to answer the question. So that's the reason I'm just suggesting this way. Now, coming to this question, we will do all 3 concepts. Vertex, and I'll tell you how to count an edge also, and I'll tell you how to count surface. Okay. So I think we can proceed with edge and surface for the top example also. See, this one, you got to know how to find a vertex. Vertex is nothing but we have 17. Now coming to edges. Edges is nothing but it's a line between 2 points. I need to count how many edges are there. I'll start from top to bottom. Okay. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. And parallel to this, it will be there, that's 10. And we have here 11, 12, 13. And this is 14, 15, 16, 17, 18, 19, 20, 21. Is it 21 is visible?
Yes, sir.
Yes, ma'am.
Now I need to know how many are hidden and I need to know how many are with respect to the shapes. Now coming to the point. It's a rectangle as if I told you in the beginning. Right? Rectangle means how many edges will be there?
4.
4, ma'am.
4. But always whenever you view a figure, you can see only 2. So 2 more will be left out. So 2 is hidden when it comes to bottom. Now always remember when it's a 3D figure, you need some support from here to the bottom. Do you agree?
Yes, sir.
Yes, ma'am.
I'll show you a proper yeah, I'll show you with this. See, I need a proper support from here to the bottom. Then this bottom is joined to here and this is joined to here. Right?
Yes, sir.
So I will have always 3 edges are fixed which is hidden. Okay, remember in vertex it will be only 1, but when it comes to edges it's 3. Okay, 3 edges are hidden. And one more is, can you see this L shape? Right? I need
Yes,
to
ma'am.
have one more line here, right? So which is 1.
Yes, ma'am.
So totally this 25 edges will be there for this question.
Ma'am, I'm sorry, could you repeat how to count edges from the beginning?
Yes,
I'm getting
I'll
confused
repeat.
little bit.
I'll repeat. Don't worry. So when you're counting these edges, I'll just count now properly. Just see. I'll count from top to bottom. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and parallel to this it will be there, which is 21. 21 we can see visible. Now I need to count about hidden. Hidden, how it works, I'll show you. Just see, hidden, how it works, I'll show you here. When it comes to hidden, generally, whenever you're taking a bottom has to be something like this. Okay? Now, when I'm trying to construct this, bottom there are 2 edges which is hidden. Plus, there will be always a vertical support here, from here to the bottom. Like this. There is a vertical support here. It's like a cuboid, right? And you need to have one more line also over here, which should be a cuboid. So generally, whenever you're counting the edges, 3 will be always hidden. Okay, always hidden. It's always. Okay, and this will be with respect to the figure which is visible. Now, I need to count one more point here is this L shape is given here. I've already counted this line, but I need to count this vertical line also, no? That's 1. So 21 plus 3 plus 1, which is 25. Okay?
Understood, ma'am.
Yes,
Thank you.
Yes. Same way, I need to count about surfaces. Surfaces means I told you it's just a face. Right? I need to know how many I could see. Just see now. Again, 1, 2, 3, 4. Faces means I can tell you it's shapes. Different shapes in a different view. So it's 1, 2, 3, 4, 5, 6. This is 7. Can you able to see 7 now? Do you agree? 7 faces are visible.
yes,
sir.
ma'am.
Yes, ma'am.
Now we need to count about hidden. Same way. Bottom will be hidden always. That's 1. This left side view. See, when you can't see any of the surfaces, consider that it could be any type, like it could have multiple surfaces also. But you can't see, no? Consider that it's a single flat surface. Don't even think about the other surfaces. Think that it's a single flat surface. Bottom is 1, this is 1, and back is 1. Always 3 surfaces will be hidden. Okay? See, in vertex may 1 will be always hidden. In edges may 3 will be always hidden. In surface also 3 will be always hidden. This is with respect to bottom, left or right and back. Okay. This is with respect to bottom again with 2 and vertical 1. And this is with respect to bottom. Here?
Ma'am,
Now,
I
Yes,
have a
ma'am.
doubt.
yes, Arini, tell me.
Ma'am, so for hidden surfaces, we should take it as a whole surface, not depending on the shape.
Yes, you need to consider. See,
Okay, ma'am.
here you can see there is a step, right? Don't think
Yes,
that there
ma'am.
are 2 surfaces here because I can't see, no? We can't judge when you
Yes,
can't
ma'am.
see it. Consider it as single flat surface.
Okay,
Okay,
ma'am.
same way back also and the bottom also. But there is an L shape here, right? There will be one
Yes, ma'am.
surface here,
Yes, ma'am.
right? That is also 1 with respect to the shape. So we'll have 11 surfaces.
Okay,
Everybody
ma'am.
clear?
Yes, ma'am.
Yes, sir.
Yes, ma'am.
Now we will do second example. If you get the correct answer, then we can move on to the next topic now. Here, find the number of surfaces in the given 3D structure. First thing, I need to count the vertex. How many are visible and how many are hidden? This will be total. Can you tell me how many are visible and hidden?
Three, ma'am.
What, 3? I didn't get you. Can you repeat again?
3 is hidden, ma'am.
3 is hidden.
3 is hidden. Okay, just count how many are visible.
3 is
19.
hidden. 9 are there.
9 are visible.
19.
19.
Okay, 19 plus 3. Are you saying it's
21, ma'am.
21 now? 19 plus 3 is how
No,
much?
no, it's 18.
It's 19 or 18?
18 only.
18, 18.
18. Okay. 3 plus. Okay. Let me just show you here how it is works. I'll come from top to bottom. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 are visible, no?
Yes, sir.
Now, the point. How did you say bottom is 2? How did you say bottom is 3? Sorry, not 2. 3. How did you say bottom is 3? Bottom should be always 1, no?
1.
You remember I told you this in the beginning only. Vertex may, bottom may be always 1, right? Which is with respect to this point. Do you agree?
Yes, sir.
Why is this 3? Then how come we got 3 here? It should be 1. Wait, let me just check. Is it 1? Yeah, it is 1. Are you clear now? See, remember, vertex means it's a point. Whenever you have a question here, just imagine it's a rectangle. This vertex is not visible. All other vertices are visible. Only one is hidden, no? Don't get confused with vertex and edges.
Okay, ma'am.
Okay, very clear. Be very particular when you're talking about vertex and edges. Are you all clear now, vertex?
Yes,
Yes,
ma'am.
ma'am.
We'll move on to edges. Can you just tell me how many are visible and how many are hidden when it comes to edges? How many will be hidden?
3 hidden edges.
3 hidden, correct. Now coming to the edges, count how many are visible.
23.
Is it 23 things?
Now, what's the question again?
How many are visible edges?
23.
23 you're saying? Okay, 3 are hidden. Okay, let me just count. 1, 2, 3, 4, 5, 6, 7, 8, 9,
25.
10, 11, 12, 13, 14, 15,
25.
16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 are visible. Where you're missing? Where you're going wrong? Just think. I'll tell you. Where you would have went wrong, You would have forgot to count this one sometime. Right?
So,
Remember one point. All the lines, small line also becomes an edge. This is also an edge. This is also an edge. All the lines are edge. So there are 27 lines plus 3 lines are hidden. What is the 3 lines? One is from here to here. The other one is from here to here. And from top to bottom. These 3 are hidden always. Okay, totally it will be 30. Is that clear, guys?
Yes,
Be very
ma'am.
clear when
yes,
you're
ma'am.
counting. See,
Yes,
don't
ma'am.
go wrong. Follow certain rule. Either it could be from top to bottom or we are doing from left to right. Anyways, but be very particular when you're doing the method. Don't do randoms, okay? Now coming to faces. How many faces will be hidden generally?
1.
Ah,
Actually, no,
no.
3. 3, 3, 3.
Three,
Three.
huh?
Three faces. Three
Three
faces.
faces.
Faces are hidden. Fix it. Coming to this figure, how many are visible? Just count visible one now.
9.
9.
9,
8.
ma'am.
Okay.
9.
8
9.
or 9? Okay,
9.
let's just
9.
check.
9.
1, 2, 3, 4, 5, 6, 7, 8, 9. Don't miss any of these surfaces. So it's 9 correct. So totally you will get 12. Are you clear now how to count it?
Yes, ma'am.
Yes, ma'am.
Why I'm taking much time for this particular topic? Because this topic is needed for all other visual topics. That's the reason I'm just taking much time for this. Are you all clear now?
Yes,
It's a
ma'am.
very, very
Yes,
important.
ma'am.
Yes,
Okay,
ma'am.
good. Can we do the third
Yes,
example? Then
ma'am.
we'll move on to the next. Yeah. Tell me how many vertices fast, hidden and visible. This is edges and
Hidden,
hidden.
hidden vertices are 1.
Yes.
Then edges is 3.
Hidden vertices for this particular figure won't be one. Think and tell me.
Okay.
Particularly this vertex. I'll tell you why it is. Because
2.
the shape is not rectangle.
Ma'am, 2.
2. Okay. How many are visible then?
Ma'am, isn't it 3?
It is 3. Yes. Plus 1. Because from this to the bottom, one vertex will be there. No, that vertex. And here to here, bottom one vertex. And here to here, bottom one vertex. 3 bottom will be like 3 vertices will be hidden. Yes.
20 are
Okay.
visible.
20 are visible. Okay, wait. Let me just see.
Ma'am, there would be one more vertex.
Okay, wait. Let me just
Ma'am, there
count.
would be one more hidden vertex.
Okay, 1 minute. 1 minute. I will show you. Okay, we'll take different colors for different questions. I'll just move on to the yellow one. We'll talk about the vertices now. I need to count how many vertices are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 are visible. Do you agree?
Yes, ma'am.
Yes, ma'am.
Okay, coming to hidden. One more bottom with respect to this. That will be hidden. 1, 2, 3, 4. There are 4 which is hidden. Do you agree?
Yes,
Yes.
ma'am.
Yes, ma'am.
So 22 will be our hidden like total vertices. Coming to edges.
I have a doubt for the
Yes,
vertices.
Aditya. Yes,
Do
tell me.
the vertices for the bottom part of the slope in account?
No, bottom part of the slope is visible, no?
No,
Let
as
me
in
see.
the back part of it.
No. Because when you can't see, don't even judge about it. Don't even think about it.
That okay.
See, bottom, why I'm telling you hidden? in the bottom because obviously with respect to the shape, we will get to know there is a vertex at the bottom, right? With respect to the top faces or with respect to the side views. But when it comes to this slanting, we don't know about the bottom, how it will be. So just leave it. No issues.
Okay, cool.
Now coming to the edges point, I'll tell you how to do about the edges now. How many are visible in edges? Because we have a minute edges also here. Please count properly.
27.
Are visible?
27.
Yes,
Are
ma'am.
visible?
27.
Okay.
No,
How
yes,
many are
ma'am.
27.
hidden?
Visible.
How many are hidden?
Ma'am, 5 are hidden.
Ma'am, 5.
Okay, you're saying 5. So totally you're saying it's 32, right? Okay, let me just count and clear it. So I'll start with the left and throw right. So it's 1, 2, 3, 4, 5. This slanting is 6, 7. One more slanting should. Okay, I'll just count the visible one.
Ma'am, I
So
think
7.
hidden is 7.
Okay, wait. Let me just come to the point now. I'll just go with the thinner lines. So it could be proper now. Okay. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. How did you say 27 are visible? I'm getting 23.
Ma'am, you missed one, the bottom of the slope, 24.
Okay, 24. Okay. 24 is correct. Then how come 27? Did we miss anywhere? No, right?
No, ma'am.
Okay. Okay, according to me, I'll just move on. It's 24 plus. Now I'll count to hidden one. So slanting one more should be there. That's first hidden. Then from here to here. Wait, I'll just erase this part. I'll show you the hidden one now. Slanting one should be there here. That's 1 and 2. Right? 3, 4, 5, 6, 7, 8, and 8,
Is it 7 or
8 will be there, and this will be 9, no? 1, 2, 3, 4, 5, 6, 7. There will be one more 6 here, 8, and there is 9. 9 are hidden?
Yes, ma'am.
9 are hidden, plus 24, which is nothing but 33.
Yeah, ma'am, one is left, right?
Which one?
Yeah. Ma'am, the dark blue one that you, the below it. Yes, ma'am.
This one.
Yeah, that below one. Yes, ma'am.
Oh, yeah, we have one
Yes,
more
ma'am.
here.
Yes,
Yes,
ma'am.
10. Correct. That's 34, correct. Yeah, totally it's 34. So when we are predicting our answer, we need to follow a proper rule. Then we could get a proper answer. Okay. So remember when we are doing this particular way, we can get a proper answer. See, I think when I found the just from that way, I went wrong. So you need to follow the proper way. Either it could be from left to right, or right to left, or top to bottom, or bottom to top. Okay. Now coming to the point of surfaces. How many surfaces are visible and how many are hidden? Fast. How many are visible and how many are hidden?
3
Ma'am,
surfaces,
7 are visible,
ma'am,
right?
8 are visible.
3
8 are
are
visible.
Okay.
8 or 7?
7 are visible.
1,
7 are
2,
visible, right?
3, 4, 5, 6, 7. 7 are visible. Correct.
Yes, ma'am.
Now coming to hidden.
4,
4 you're saying. Okay, 1 is here. 2 is here. 3 is here. 4 is here. 5 is here.
And 7
ma'am.
again 7.
6.
And then
Yes,
ma'am,
one
triangle
more.
one.
Yeah, one more here. 7.
Yes, ma'am. 7.
So 7. Correct. So totally you'll have 14.
Ma'am, bottom
And
surface is also included, ma'am. For the
Yeah.
face.
Yeah. Bottom is also a face, no? When you're counting your room, you consider the floor also, no? Like
Yes,
that,
ma'am.
the bottom is also a face. Okay. So remember, when you're counting the surfaces, edges, and vertices, we have to be very particular with respect to the shapes and the things. Okay. Here. So now coming to the next, we'll move on to counting of figures. See, counting of figures, we have different shapes. Just a second, 1 minute. Yeah, sorry. Okay, we're coming to the counting of figures. See, counting of figures, I'll tell you few logics when it comes to the questions, okay? When we are counting a straight line, I can do it in two ways, okay? One is in, I can count the end points and divide by 2. I can just count the corners, the end points and divide by 2. That could be one way. Then the next way, I can go with the properties. What is this properties means? I can just tell you different types of properties. First is vertical lines, how many are there? Horizontal, how many are there? Slanting, how many are there? Like that. There are two ways of slanting. One is left slanting. The other one is right slanting. There's 4 categories. I'll fix these 4 categories generally. Then what I'll do is I'll just show you. I'll count how many vertices, how many horizontal, how many left slanting, how many right slanting. Then I'll just total it up. I'll get the answer. But when it comes to randomly drawn lines like this, it's very difficult for us to count how many are left count slanting, how many are right slanting, how many are vertices like vertex, like vertical, how many are horizontal. It's very confusing. When you have this kind of cases, you can go with intersection. How to go with intersection also I'll tell you. When you're planning to go for intersection, fix few lines because all the lines looks like intersecting each other. Do you all agree? All the lines looks like intersecting each other. Right?
Yes.
One
Yes,
of the
ma'am.
line it is getting intersected. So what I do is I'll just show you with respect to this randomly drawn how it could proceed. See, I'll fix 4 lines. One is this line. The other one is this line. I'll take a horizontal line only to fix it up. This is third line and this could be fourth line. Okay. I'll take like this. This is second line. This is first line, third line, fourth line. Now I'll take the first line. I'll count how many lines are intersecting the first one. How many lines are intersecting the first one? So it's 1, 2, 3, 4, 5, 6, 7, 8, including that line. Is it nothing but 9?
Is it 9?
Yes,
Yeah,
ma'am.
9.
including that line, it's 9. Correct. Coming to the second one now, line number 2. When I'm taking line number 2, I need to remove the lines which are touching 1. I need to count only the lines which touch 2. Okay, this is 1. This is 2. No more. Including that line, it's 3. Okay. Coming to the next third line, I'll count the lines which are not touching 1 and 2. Okay. So I'll just start with it. So it's 1. This is touching 2. This is 3, no? 1 and 2. This is 2. 3. 4. 5. And this is 6. Including that line, it's 7. Am I right?
Yes.
Now coming to the fourth one, I need to count the lines which are not touching. 1, 2, 3. So it's 1. Then next it should be 1 is done.
Ma'am, can you explain this again?
Yeah, I'll explain it. 1 is done, 2 is here, and these are the lines which are, I think it should be counted here. And this should be 2. Okay, let me just repeat it. See, I'll take the lines which are horizontal and I'll fix that line. Okay. This is third line. Okay. Yeah, and this is fourth line. I'll fix few lines and then I'll go work for the questions. What I do is I'll count the lines which are intersecting 1. How many lines are intersecting 1? I need to see. So it's 1, 2, 3, 4, 5, 6, 7, 8. Including that line, it's 9. There are 9 lines which is intersecting line number 1. Go to line number 2. Count the lines which are not intersecting 1. Okay, it's 1. Then it's 2. Then it's 3. Now coming to the point of third, I need to count the lines which are not intersecting 1 and 2. Count the lines which are not intersecting 1 and 2, which is 1, 2, 3, 4, and we have 5. We have 6 here, and we have 7. Yeah. So 7 lines are there which are non-intersecting. Let me just recount again. It's 1, 2, 3, 4.
At the left end.
Oh yeah, it's 8. 8 lines are intersecting line number 3. Okay. Now coming to the next line number 4, I'll have only only that line which is 2, and one more line which is non-intersecting with the other things. Everything is counted. Yeah, all of them are counted. Can you just add this up? Which is nothing but 22. Do you agree?
Yes, ma'am.
There are total 22 straight lines. This is one way of doing it. Or else you can do one more way also. Just see. Count these lines. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll have 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. So 44 divided by 2, which is nothing but 22. I can get like this also. You can do it in both the ways. Anyways, which is convenient for you, just try it in that way. Okay?
How did we divide by 2, ma'am?
Because straight line has 2 endpoints.
Okay, so we
I'll count all the endpoints and divide by 2. That's it.
Okay.
Okay. So we can do straight lines like this, or else when there is a particular lines drawn like this, just think they would have just drawn something like this. And if they are asking you to count how many straight lines are there in this particular figure, if you can have like this, then go for a vertical, horizontal, left slanting and right slanting. What is this left slanting and right slanting is? Left top say, right bottom, if you have any slanting line, it's left slanting. Right top say, left bottom if you have anything, which is right slanting. Okay. Just segregate your lines in this ways and just count it. Okay, that is one more point.
Can you repeat?
Could you repeat the left and right slanting?
Yes, I'll tell you the left side and the right side. Left side slanting and right slanting is, left slanting is you'll have left top corner as a top and bottom will be at the right bottom. This type of slanting we say left slanting. Then go for the right slanting, which is right side top and left will be bottom. This is right slanting. Okay?
Okay, ma'am.
Yeah, you can just do like that also. Okay? Coming to the next here. Now in the second figure, can you see this? How many circles, squares and triangles can you see in this given image? How many circles, squares, triangles can you see in this given image?
2 circles.
Yeah, two circles,
Yes.
two squares, and one triangle.
One triangle
Two
only.
circles, 2 squares and 1 triangle. Yes, very
One
good.
triangle.
Yeah, that's correct. 2 circles, 2 squares and 1 triangle. Yeah, correct. And I think this is the answer of 22, right? Yeah, correct. Okay, coming to the third one now. Now I need to find some particular letter. Okay, I need to find the letter T exactly how it is and how many T's are there in this figure. I told you whenever we do visual questions, I need to have a proper following, like a proper rule. If I'm going from left to right always, then go from left to right always. If I go from top to bottom always, then go from top to bottom. Okay. Anyways, but just follow the same rule for all the questions so that you won't get confused. Now tell me how many T's are there here? Only T. Don't divide I into 2 different ways and say 2 T's are there. And don't divide H into 2 different ways and say 2 T's are there over there. T means it should be property. Yes.
Then 7.
7. Okay, what about others?
Ma'am, I only got 4.
You only got 4. Oh, I think it went up. 1 second.
Ma'am, I'm also getting 7.
You are also getting 7. Okay. Let me just show you. Okay, I usually go from top to bottom towards right side. So I'll just start from this. This is 1. This is 2, 3, 4, 5, 6, and this is 7. Totally 7 T's are there. Okay. Clear? So when we do a particular way, we get an accurate answer also, and we won't get confused also much. The confusion could be avoided. So when you have this type of figures, how to count the circles? You can go with different colors. I think this is very tiny, like you can't see color differentiation properly here. But in your exam, you'll have a proper color differentiation. You can count generally how many circles are there with respect to the colors. You can say green circles are this much, red circles are this much, blue circles are this much. Then totally all together will be this much. Okay, like that you could able to predict. Okay. Yeah, coming to this fifth one. Can you see this and tell me how many black diamonds are there? Diamond should be diamond.
Ma'am, 12.
12. And don't say trapezium, don't divide trapezium into 2 different shapes and say 2 diamonds are there in a. Okay, diamond is proper, diamond should be there. So I'll just go with that. I'll just start from top right to this. So this is 1, 2, 3, 4.
Ma'am, I'm getting 14.
Okay, 5, 6, 7, 8, 9, 10, 11. It's 12. How did you get 14? 2 more? Where is 2 more?
Ma'am, I believe that you missed one. It was the first one fused with another triangle. So I think I might have also counted that one also.
Which one?
That which one? Yeah, next. Next to that. Next to that. Yeah.
No,
Not
no,
this.
this is not a
No,
diamond.
next to that. Yeah.
This one?
Yes,
No,
ma'am.
no. Are you all clear? See, when we are counting a diamond, it should be a proper diamond. Okay?
Okay.
See, these and all is a pretty easy question. So no need of particular definitions or shortcuts to do it. And here also, how many triangles can you form by joining the below group of dots so that 3 dots are left? You need to form a triangle, but 3 dots you need to leave. How many triangles you could form?
Is it 4?
No 4. It should be more than 4.
Is it 11?
8.
Give your option and go with your answer, please.
8.
Ma'am, then 12.
See, I'll tell you one point, major point. When you have this kind of option, you can't have 24 for sure. Rule out this 24. Between these three should be your
6,
answer.
ma'am.
6.
Ma'am,
Ma'am,
8.
Okay.
it's 12.
Okay. Why is this
8.
confusion? One second. I can draw this kind of triangle too. Do you agree?
Yes, ma'am.
Yes.
Okay. I can draw 3 dots should left empty, right? This should be 2.
Ma'am,
Correct?
then only two dots will be remaining, right?
No, this is no empty.
Oh,
Correct. I'm not using that dot, right? Are you clear? So the point is I should not join the thing. No, 3 dots are still left. So 1, 2, 3. So 2 more like that.
then
Then
it should be 8.
I'll just tell you one second. We can plan it in this way also. Yeah. I could do one more like this. I could get like that 4. Am I right?
Yes, ma'am.
One will be in this direction
Yes,
and
ma'am.
one will be in this direction. And one will be from top to bottom. The other one will be same from top to bottom. We get 4. Okay. Next.
Ma'am, I think 24 is the answer.
24 it can't be. She said it can't be that.
24. How come 24?
Is it 12?
There's a
No,
lot of triangles in that for sure.
12.
See,
Ma'am, it
24
will
won't
be
be
12.
possible because I'll tell you one point. We have only 7 dots, right? You can't form 24 different triangles. That's impossible. In that 7 dots also, we need to leave 3 dots empty. So I have only 4 dots. Using 4 dots, how many triangles I could form? So 24 is like 8 different triangles. I can't find 8 different triangles when we are leaving 3. Right? So in that way, I think 24 could be impossible. It could be 12, I guess. Let me
Ma'am,
just
it's
try.
12.
Yeah, I'll tell you why. We already got the answer above 8. And I ignored 24 directly because we can't form 28 at all, 24 at all. See, this is one kind of 2 triangles. What do you get? And this is 4. Oh yeah, obtuse. Obtuse angle, you'll get 4. Then we'll get this. Okay? I can do it by elimination also when we have this kind of figures.
Okay,
We can
ma'am,
do it by elimination.
I have a
Yes,
doubt.
Yes.
Okay, if you take the center dot, the
Mhm.
bottom center dot, and the top left dot, that becomes a triangle.
Bottom center dot and top left.
Top
Okay.
top left, bottom center, and the center dot. That is also a triangle, but that isn't
But
account.
you're leaving 4 dots. No, I need to leave only 3.
Oh, okay, I didn't read
There's a
that.
condition on that part also. No, we need to leave only 3.
That's my bad. Sorry.
Ma'am,
Okay.
we should leave only 3, ma'am.
Yeah, we should leave only 3 dots.
Yeah. So, ma'am, the correct answer is 8 or 12.
It's 12, but in your paper it is given as 8. The answer key paper may. But actually it is 12. It's not 8.
But
Okay.
in the below that it's written, please note the right answer as per NID BS Design
That's what
2016.
saying. In your paper answer key they were given as 8. But actually it is not 8. It's 12. That's the reason it wasn't read. But actual answer is 12. Clear?
Okay, ma'am.
Sometimes happens, you know, in your exam also you may get a question answers as wrong. Right? They'll give our answers wrong and they'll give a grace mark to everybody. You understand? So
Yes,
in
sir.
that cases, that could be also possible. That's the reason. Okay, can you see how many triangles are there in this? Will it be easy for us to count within a 1 minute how many triangles are in this there in this particular figure?
No, ma'am.
No, right? But I'll tell you one point, easy way. Simple. First thing, go for this. First, divide this figure. Do we have two hexagons together?
Yes, sir.
Yes, ma'am.
Okay.
Yes, ma'am.
In one hexagon, there is a sectors now, right? They are dividing it into 6 parts. Do you agree?
Yes, sir.
Yes,
Yes,
ma'am.
ma'am.
So in first hexagon, I have 6 triangle. In second hexagon, I have 6 triangle. Correct?
Yes,
Yes,
ma'am.
ma'am.
When I include together, I'll have 12 triangles. Can you see the smaller triangle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right?
Yes, ma'am.
Okay. Now coming to this. I have counted all the triangles which is there, a little bigger one. Now coming to this corner. Can you see this?
Ah, yes.
Particular this part, I will have 3 triangles in this. You know what it is? I have a triangle like this, correct? I have 1 is here, 2 is here, and 3 is this all together.
There are
Okay.
24.
Yeah. 3 12s are, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because both hexagon are together, right? It's 12 into 3. So which is nothing but 36. 36 plus 12 plus 12. You know why this 12? This 12 is this too. And this 12 is here. And 36 is here. Can you just total up?
60.
Sum up
60.
60. Okay. Let me just find out. Is it 60 or more than 60?
Then there would be more.
Wait. 1, 2, 3, 4, 5, 6, 7, 8. This is 12.
Yep,
12.
Ma'am,
formed
there
by
will
the
be more, right?
mixture of more hexagon,
One
those
second,
two
one second,
hexagons.
one second. Sorry. So yeah, we have 12. 3s are 36 is done. That's correct. This is done, 36. And the smaller parts are 12. Yes.
Ma'am, I think the
And
smaller parts may be 24.
how come? No.
Ma'am, because each triangle can be seen in 2 ways.
Oh, wait. 1 second. Oh yeah, sorry.
Yeah.
Ma'am, we
That's my
can
bad.
take one hole as a triangle and then fill it.
Big one.
Just a minute. When you take an hexagon here, first hexagon, right? So they have just divided this into 6. I just told you this, but they just made like this also, no? In one hexagon, we have 12,
Yes,
right?
ma'am.
So in 2 hexagon, it will be 24, right?
Yeah, yes, ma'am. And there would be some
Yes,
triangles
correct.
formed by
24
the
plus 36 is
mixture of
correct.
both hexagons.
Yes, correct. I'll tell you now. Sorry. That's my bad. I didn't see that. See, my point is first thing, I'll just take this particular hexagon, which I draw like this one. Okay. Okay. And my segregation of this will be this one. And one more vertex is here. Yes. This is done. And we have this line. Okay. In one hexagon, I will have 12 smaller one. Okay. Plus the bigger one is 6. Right? Plus same way when I take a second hexagon, I have 12 smaller one and the bigger one is 6. Then if I take the smaller one, I'll have 12 into 3, which is 36.
36 plus 6.
So totally 36 plus
No,
24.
30.
Yeah, 36 plus 24 is 72. So 72 would be your correct answer.
Yes.
right?
Ma'am.
Yeah, correct. 72 would be the correct answer. Okay, so what we do is when we have a two complex figure, divide that into sectors or a simple one, then just try to mingle it up, like mix it up, you'll get the answer. See, I'll show you the next way. Here. Oh, not this one. This one. How many squares you could see here? Square should be proper square.
$28.
Ma'am,
28.
I'm getting 25.
Ma'am, 29.
28,
28,
25, 29. Okay.
15.
So, okay, let me just
Ma'am,
put
I'm
1,
getting
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, sorry, 16, 17,
25, I think.
5. Okay, 5, 5. Together, anywhere, do we get? Okay, let me just find out this. Right.
25.
Yes, 25 is
Yes,
correct.
ma'am.
25 is correct. Okay. Yeah. Next. Okay. Can you try this one? See, I'll tell you a shortcut way to count the squares and the triangles. Just a second. Yeah, sorry guys, sorry. See, when I'll show you a small trick to solve the square and this one. Whenever you have a square, if you have a lines like this, okay, that means the number of rows and number of columns are equal. What you can do is, there'll be some questions saying that count how many squares are there. For example, if they ask you count how many squares are there in your chessboard, how did you proceed when you just go with the chessboard? How many squares are there in the chessboard?
64.
64.
No, no, no,
12.
no, no. No, it's more than 200. You know how? I'll tell you. See, for example, I'll take with this 3 cross 3. How many squares are there with 3 cross 3? Don't say 9, please. Yeah, tell me. How many are there?
18, right?
18. No,
14.
14. Okay, let me just tell you in that way. See, I'll just tell you. When you're taking this 3 cross 3, I'll go with this. So how many sectors are there? We have this 3 separations, correct?
22.
I'll tell you. We have the 3 separation. 1 segment, 2 segment, and 3 segment. Just
Yes, ma'am.
square it up and add it. We'll have 1 square is 1, 2 square is 4, and 3 square is 9. You will have 14 squares in this particular figure. How it is 14, I'll tell you. See, the smaller one we have 9. Correct?
Yes.
Right?
Yes.
Come
Yes,
into
ma'am.
2 together. See, this is 1 square and this is 2 square and this is 3 square and this is 4 square. Do you agree that 4?
Yes.
And the entire one is 5. That's 1. Okay. This is simple one. I got it. When I'm talking about chessboard, it's 8 cross 8. Am I right?
Yes,
It's 8
ma'am.
rows and 8
Yes, ma'am.
columns. So what I need to do, I need to write this 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square plus 7 square plus 8 square. Now I'll have to just add it up. 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49 plus 64. I need to just get an answer for this now. Okay, keep solving this and tell me what's the total. What's the total for this?
204. 204.
204? Is it so?
Two not four.
Yeah, that's it. There'll be 204 squares in your chessboard. Very easy. When you have the number of rows and number of columns are same, if they ask you to count how many squares are there in it, you can just go with this way. Okay? Simple?
Yes, ma'am.
Same
Yes,
way when
ma'am.
you have a triangle like this, if they ask you to count how many triangles are there in this particular figure, okay? Same thing. See how many sectors are there here? It's 1, 2, 3. Okay, 3. 3 are there, right? How many rows are there? 4 rows. 4 into, it's 1 plus 2 plus 3, which is 4 into 6, which is 24. There will be 24 triangles in this. You know how it is 24? I'll tell you. This one is the entire one. Okay? This 2 stands for 1. And from here to here, it's one more, which is 2. Okay? And this
Yes,
3
ma'am.
stands for this individual. See, this is 1, this is 2, and this is 3. Okay, like this, I have 4 different segments, right? 4 different rows. If I take the smaller one also, I'll have the same way. It's 1. Okay, this is 2. And this individual is 3. Then go for this again. It's 1, 2, 3. Entire one is again 4. So then 2 together, again you'll have 6. Okay. So instead of counting each and individual thing, you have to just multiply this and solve it. Okay, 1 second. Can you just give a try for this question now?
Is it 79?
75.
Ma'am, even I got 79.
What is the answer for this particular figure?
Ma'am, 79.
79. Okay,
75.
I'll tell you how to count this first. See, we have a 4 different separation here. This one, this one, this one, and this one. All 4 look same.
So
First count how many are there in the one figure. Okay, I'll just go with the outer one. See, outer one is a diamond. We have 1 square. Plus, go to the inner one. Inner one is nothing but 2 cross 2. 2 rows and 2 columns.
yes, sir.
How many squares should be there for 2 rows and 2 columns? Just now I told you, no? If it is 2 rows and 2 columns, how many squares should be there?
4.
4 or 5?
5. Ma'am, 5.
5. 5. 5. Next, again, it's a diamond shape. Can you see this third one? Third one is a small diamond. We have 1. Again, it's 2 cross 2.
Yes, sir.
Again, it's 5. So it's 12 in one figure. Do you agree?
Yes, ma'am.
Yes, ma'am.
Ma'am, we are
So 12
counting the
fours are.
ma'am, we are
Yes,
counting the hidden figures also.
not hidden. I'm just counting the. Here, there is no hidden figures. No. All are visible figures only, right?
Yes, sir.
See, I'll tell you. When I take like this, the 2 cross 2, why I told you 5, you know, the smaller triangles are 1, 1, correct? There are 4
Okay.
smaller triangles and 1
Okay.
bigger one, no, which is 5.
Yes, sir.
That's why it's 5.
Okay.
Okay. So it's 12 into 4, you have this. Now the outer square, can you just take the outer square? 4 cross 4. 4 cross 4 means how many squares should be there?
1.
4 cross 4. 4 rows and 4 columns. How many squares?
30.
30, 30.
16.
No, I'll tell you. 4 cross 4 means, I'll tell you, it should be 1 square plus 2 square plus 3 square plus 4 square. Okay, this is what 4 cross 4. So when you add it up, you'll have 1 plus 4 plus 9 plus 16. What is the summation of this?
30, ma'am.
30.
So 12 plus 30 is 42, correct?
Yes, ma'am.
Yes, sir.
Yes. Now coming to this point. See, diamond shapes are individual shapes, right? We need to count that way, right? So in that cases, I have 1, 2 cross 2, 5, 1, 2 cross 2, 5, 12, 12, 12, 12, 12, 12 fours are 12 fours are 48 plus 30 plus, can you see this middle one, this diamond, right? That's the only one which is left empty, right? We didn't count that. So if you add that also over here and count how many are there now? How many are there now? 48 plus 30 plus 1.
32.
48 plus 30 plus 1. What is the answer?
79.
79 squares will be there here. I'll repeat again. When you have the same kind of squares like this, it has 4 segments. I'll count in one figure how many are there. In one figure, there is 12. So there are 4 figures, right? 12 into 4 is 48. You understood how I got 48 now?
Sure.
Now, coming
Mom,
to
I
the...
didn't understand how you got 12. The 1 plus 5 plus 1 plus 5.
See, I'll tell you. When you take this shape, this particular shape. Okay, wait, I'll remove this colored one so that you could see properly. Okay. Now, when I take this diamond, it's 1. Do you agree?
Yes, ma'am.
Then next, when you take this one, I have 2 cross 2. Right?
Yes, ma'am.
2 cross 2 is nothing but 5.
Yes, ma'am.
Again, when you take diamond, you will have 1.
Yes, ma'am.
Again, we have 2 cross 3, 2 inside. Can you see this?
Yes, ma'am.
So that's why it's 1, 5, 1, 5.
Okay, ma'am.
I got 12. 12 into 4, which is 48. Then I'll take this outer one. I have 4 rows and 4 columns. Okay, I'll count that way. So in that case, I'll get 30 for this total. All the squares are counted except this diagonal. I'll add 1 to this. So I'll get 79 as the total. Okay?
Okay, ma'am.
Yes, ma'am.
So when you're counting the squares or any complex figure, just try to divide it and do it. So that you could get the answer much more easier way. Okay? Counting of figures are clear?
Yes, ma'am.
Yes,
Now
ma'am.
coming to the next one, we have mirror and water image. So how do we go with mirror and water image? How do you define mirror image?
A flipped version of the original image.
Flip version. In what way do we
Laterally
do this?
inverted.
Laterally inverted. Yes, that word is very, very important. It's a laterally inverted one, we say mirror. Vertically inverted one, we say water. What is the difference between laterally and vertically is, see, when you take a mirror and water image, you have to be very clear when you're saying this. See, we need to know which one is a mirror image of this particular figure. Which one is the mirror image? Actually, the inner side, whatever the shapes are there, it
Option
should be
3.
constant. Yes.
3. Option 3.
Yes, correct. Very
Option
good.
3.
Option 3 is
3.
correct. So you understand how the mirror images are, right? Same way, can you try this one?
Ma'am, option 4, ma'am.
Option 4, okay. Is it
Option
right,
4.
option 4?
Option 4.
Yeah, okay. Can you tell me here?
Ma'am, 4.
4,
4
ma'am.
again? Okay, can you tell me here?
Ma'am, B, ma'am.
B?
Option
No, no,
B.
actually,
B or A? It's a water
the
image,
A,
no?
ma'am.
B.
Option A. Option A.
Oh, it's a
Ma'am,
It's not mirror, it's water.
ma'am, B.
B.
Sorry, B, no, B, sorry, B. I just clicked on word. Sorry, B is correct. Okay, next. What about this?
Three, ma'am.
Option
C.
option 3.
3.
Option 3. That's good. Can you tell me here? See, whenever you have a square, it means it's a multiple choice question. Multiple answers will be there. Multiple selection questions.
Ma'am, B, ma'am.
It can
D,
be
ma'am.
option
D, ma'am.
D.
D
It
only,
can
ma'am.
be only option D.
Only D.
Only,
Yeah, only D.
only D, ma'am.
So
Because,
how you say only D? Why can't be it's B?
ma'am, because in that top part, it's showing the continuous line. Here in bottom one, it
Yeah.
should also.
See, I'll tell you one point.
Ma'am, I
When
think
the
it's
top,
B.
it's
It
D.
can be B or D.
It can be B or D because I need a diamond shape in the middle. I need to have a pattern in the left hand side and the right hand side, right? I can have either a B way or I can have either a D way. It's MSQ. I said it's MSQ because you have option as a square. That means multiple answers will be correct. You need to be very careful when you have MSQ. Okay? Now,
Yes, ma'am.
okay. So mirror and water is very easy. It's almost done. Now we have one more topic which is very interesting topic, you know. I'll just do that and then pause it, okay? So it's 2D verbal translation. Verbal translation means the word itself says Verbal, just a verbal translation, okay? Just a second. Yeah. It's a verbal translation. That means verbally the question will be given, you need to visualize it, what it is. Now here, how many coins can be kept around touching the edges of the same size coin? I need to know how many coins I can just put it in a so that it touches the
6, ma'am.
same size coin. 6.
6.
How are you saying 6?
I think it will be 1.
No, it is 6, correct? I'll tell you. For example, if I take a 1 rupee coin here, just think 1 rupee coin. How many coins I can place around this as 1 rupee coins?
6.
Oh, yeah.
6.
6.
6, ma'am.
6 is correct.
6.
Because 1, 1, 2, 2, I can have like this 6. Same size coin, I can place 6. Okay? Verbally, whatever the question is given, you need to visualize it and tell me the answer. Okay? That's the topic over here. Here, how many circles can be constructed touching 3 non-linear points? Non-linear points means they are not in the same line. How many circles I can construct touching all 3 non-linear points?
1.
1.
1. 1 is correct. Only 1 could be possible because they all are not in the same line. So only 1 could be
Ma'am,
possible.
can you
Yes.
explain how, ma'am?
See, randomly, if I draw 2, 3 points, okay, they are not in the same line. If I want to construct all 3 points I should touch and I want to create one circle means I can do only 1. Minimum 1 could be drawn. Maximum 1, not more than 1, right? I need all 3 points to be joined. Okay, minimum I can draw only 1.
Okay.
It can't be more than 1. That's the point. Next. How many isosceles right angle triangle can be constructed? Okay, if one side of the thing is a diameter of a circle, then the other one is touching the circle, vertex touching the circle.
2,
How many?
ma'am.
2. 2
Let
is
it be
correct.
2.
See, it's a circle. If I take a diameter, I need to draw a right isosceles triangle. What is isosceles triangle?
2 sides
2
are
of its
same.
sides are
2
equal.
sides
Two
are
sides are
same side,
equal.
one side is
See,
unequal.
this base is the diameter means I can't draw 2 diameter at all. So leave it. This will be not there. I have to take a card over here which has to be of equal length between both the sides. And one more point, it has to make 90 degree also. I can draw 2, one on the top, the other one on the bottom.
Ma'am,
Yes,
it
Satya.
be infinity.
No, it can't be infinity because for one diameter I can draw 2.
Yeah, but if we keep changing the diameter, as in the diameter.
That's different. See, they are saying one side if you take a diameter.
Yeah, but if we kept the same diameter and just drew it from 2 different points, 2 opposite points, that would still give us 2 different isosceles triangles, no?
Yeah.
So then, if we kept increasing the diameters points at a small angle, wouldn't that give us infinite isosceles triangles?
Yes, but according to this question, what they are saying is if you take one particular diameter, how many you draw?
Okay, it has to. Okay, fine, cool.
You understand? So in the question itself, they say if you take one side as one particular diameter, then how many you could draw?
Mom, but they
Okay.
haven't mentioned that one particular diameter. They've just
Not
mentioned
one
the
particular
diameter.
diameter. See, they didn't mention particular word, but what is the question is how many isosceles right angle triangle can be constructed drawn with one side as a diameter?
Yeah,
If you
but
take one side as a diameter, okay. So it's not like if you take one diameter, how many you can draw?
yeah, but
One side as a diameter.
one
Yeah.
diameter there can be 2. But if we just keep changing the diameter and
Then it will be infinity.
side
Yes,
is
I agree with it. Yeah, I agree with it because when you take one diameter, then it will be 2. If they say particularly one side of the thing is diameter, on the other things and all, if you want to count it, it will be infinity. There will be infinity diameters and you'll have infinity triangles, right?
Sure.
Wait, let me just see. It's 2 only. How many? Yeah. See, whenever you have a verbal question like this, consider it when you take a particular diameter. they are asking about. Okay, because if they tell you like how many isosceles triangle triangle can be constructed in the circle, if you take one side as a diameter, then it makes sense like we are taking a multiple diameter, right? They're saying how many isosceles triangle can be constructed with one side as a diameter of a circle and the other one is a vertex touching the circle. In that particular situation, I could draw only two. Okay, we have to go with the situation over there. Here, what is the maximum number of slices that can be obtained by cutting a cake with 4 cuts? When you
8,
take
ma'am.
a cake, I didn't
8.
say equal. How did you say equal? 8. I didn't say.
Oh.
I didn't mention anything like equal slices, no? Okay, I'll tell you how to go with this question. I think you will have your sketching classes, right? Okay, I'll just share a attendance form. Please fill it up and just leave it. Next class, maybe we'll continue once again. Please fill this form and then you can leave for your sketching class. So next class, I'll continue and I'll tell you. Don't worry.
Thank you, ma'am. Bye, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Thank you.